about the Chatlier's principle. The Chatlier's principle says that when a stress is applied to an equilibrium state, the reaction will shift to alleviate the stress. So if you look in your notes, you will see a chart which has a list of different types of stresses. One is adding or removing a chemical. When you add or remove a chemical, the reaction will shift again to alleviate the stress. Remember, equilibrium is when both sides, reactants and products, are occurring at the same rate. So, for example, if we add to the reactant side, that would mean that there's more reactants, and so that reaction would occur more quickly because it has a higher concentration. So in order to get back to equilibrium, it's going to shift to the product side. So when you add a chemical, it will shift to the opposite side you add on. And so if you remove a chemical, so we add a chemical, it will shift to the opposite side that you added it to. If you remove a chemical, then it would do the opposite. It would shift to the same side. Because what happens when you remove a chemical, say we remove some reactants, that reaction would then slow down because you had less concentration. And so in order to reestablish equilibrium, you would have to, your products would be occurring at a faster rate, so you would end up with more reactants being formed, so the reaction's shifting to the left. So again, if you add a chemical, you shift to the opposite side. If you remove a chemical, you shift to the same side. Now, if we increase temperature and decrease temperature, temperature changes are dependent upon whether the reaction is endothermic or exothermic. So let's say, for example, it were exothermic. If it were exothermic, that means heat would be a product. So again, if you increase the temperature, you're going to increase the heat, making the product side going more quickly, and therefore shifting to the left. If you remove heat, again you're removing from the products, then it's going to shift back to the products. So temperature, like concentration or the adding or removing a chemical, would work the exact same way. If you add heat to the side that heat is on, it will shift to the opposite side. If you're increasing the temperature or adding heat, or removing heat, or decreasing the temperature, then it's going to shift to the same side. Increasing and decreasing pressure. If you remember Boyle's law, pressure and volume are inversely proportional. So what I like to do is think about pressure in terms of volume, so, and how much space you have. So if you increase your pressure, what happens to the volume? Right, you decrease your volume. Okay? So if pressure goes up, your volume goes down, which means you have less space. Now pressure and volume are only affect gases. Okay? So the way this works is, if you increase your pressure, you have less space. So your reaction would shift to the side with least moles of gas. Okay. So if you increase your pressure, it goes to the side with least moles of gas. If you decrease your pressure, you have more space, higher volume, and it would shift to the side with the most moles. It would be the opposite. So again, if you increase your pressure, which is a reduction in volume, you shift to the side the least moles of gas. And this only applies to gases. Pressure has no effect on aqueous solutions at all. And then finally, if we add a catalyst, if you recall from earlier in the week, a catalyst reduces the activation energy. And so if you're reducing the activation energy, you're going to be doing that for both reactions, the forward and the reverse, reactants to products and products to reactants. So if you remember, we looked at potential energy diagrams earlier, where your reactants are down here and products here. If you add a catalyst, all it's going to do is reduce the activation energy. and when it reduces the activation energy, it's reducing it for both reactions. So your reactants would go faster and your products would go faster. Therefore, a catalyst has no effect on equilibrium. And again, it has no effect on the equilibrium, does not cause a stress, because it reduces the activation energy in both directions. All right, so let's apply this to a problem. In your notes, you have the reaction, nitrogen gas plus 3 hydrogen gas molecules, equilibrium with 2 ammonia molecules, and heat. Alright, so since heat is on the product side, this is an exothermic reaction, meaning that delta H is negative, and that is an error in your notes, so please correct it. It is negative. It's exothermic. Alright, so let's look at what's going to happen. What happens if we add hydrogen? Alright, so sometimes it's easy. I think it's easier to figure out the Chatlier's principle by using a seesaw. And so I like to make a little seesaw where I have my reactants and my products. So if I'm going to add hydrogen, that means my reactants are increasing. And if you remember when you were a kid, a seesaw, it increasing the weight, right, then makes it lower. So how do we get back to equilibrium? Well, it's got to shift towards the products. All right. So if we add hydrogen, the reaction shifts to the right towards the products. And how does that then affect the concentration of the products? Well, if we're shifting towards the products, you're going to increase your products. And then if you're shifting towards the products, you're going to be using your reactants. So the reactants are going to go down, your products are going to go up. All right, so what happens if we remove nitrogen? So let's say some nitrogen jumps off the seesaw, right? That side is going to go up because it now has less weight. And so which way is it going to shift? It's going to shift towards the reactants to make it at equilibrium again. All right, so again, if you're shifting towards the reactants, your product concentration is going to decrease, and your reactant concentration is going to increase because you're moving that direction. And then if we increase our temperature, so heat is on the product side, so if I increase the temperature, my heat is going to increase, and so my products are going to increase, and so I'm going to shift then towards the reactants. And if I'm shifting towards the reactants, my product concentration goes down and my reactant concentration goes up. Then what happens if we increase pressure? Now pressure, remember, does not involve the seesaw at all. So if we increase the pressure, right, we're decreasing our volume, which means we're going to get inside with the least number moles of gas. So how many moles of gas do we have on the left? 1 mole here plus 3. That gives us 4 moles of gas here on the left. And on the right we have 2 moles of gas. Alright, so we're going to shift inside the least moles of gas, which means we're going to be shifting to the product side. If we shift to the products, our product concentration increases and our reactant concentration decreases. And finally, what happens if we add a catalyst? And the answer for that is nothing. There's no effect from a catalyst because the catalyst increases the rate of both reactions in the same amount. And so there is no change in equilibrium. So a catalyst has no effect.